Okay, bonjour, Conseil fédéral, Monsieur Parmalin, and welcome to the National Councillor and the representative from the Ticino. Welcome, colleagues, and I'm very proud that I'm giving here a brief introduction. So, if you work at MeteoSwiss, you somehow work in the interface between research and operation, and you learn a lot about that. Bringing research into real operation, it's not an easy task. And my first thing is to say thank you, because Thomas understands that. And he helped us a lot. And it's a very nice story, and if you've heard already quite a lot about what we've done. So weather forecast is something that is used widely. It's not just one application. We have to do with all the different departments in Switzerland. We have to do with industry. It's going from road, from security, from police, fire brigades, to agriculture, to energy. But I think the thing that is most well known from MeteoSwiss is, of course, our app. And by the way, it's widely used in the industry, in aviation, even in the military, we've learned. And I hope that you use our app as well. So my little story will be here. How is Alps contributing to that app? And you will see it has a lot to do with Alps, our app. So if you want to do a forecast, of course, you need observations. You need data. And Thomas has already said, we observe in Switzerland the data, but we're also involved in the global system. So we represent Switzerland in the WMO, which is the World Meteorological Organization. Observation is the key. If you don't have observation, you not even should try to do a forecast. Second, you need a model. You need somehow bring your observations from today into the future. That you can do with a model. It's in the moment a lot of numerical weather prediction models, and in this future there will be, of course, a lot of AI models to do that. And then you need more than Switzerland. You need the globe, and we've heard that. We work very closely with ISMWF. This is our European organization that is doing the boundary condition that we need to have local simulations, more over the Alpine region, and then even more local over Switzerland. And we've heard that, so we used the model ICON. Before we were using Cosmo. That was the one model that was running on GPU for quite a while, the only operational model that was run globally on the globe on GPU. So we've heard as well that weather forecast, a lot of people rely on weather forecasts. So we need to do a lot about having a secure forecast, and in particular, what happens if one system has a problem, then we need a second one, and that was one of the efforts that CSCS has now a node as well in Lausanne, and our system is now running both in Lausanne and here in Lugano, which makes this geo-redundance, which is essential for us to have reliable and compliant forecast system. So maybe another thing to know is we run it every 3 hours. We run typically a shorter version, 1 day ahead, and then sometimes we have runs that go up to 5 days, and you will see that in an example. So how can you imagine now how this model looks like? It calculates all the parameters that you need for agriculture, for the roads, the snow, etc. But one of the most nice visualization is, of course, that if you look, how look the clouds in our Cosmo model that is running now operational since about 2 months. And you see here an animation that has been done by NVIDIA and MeteoSwiss together with a lot of help. And you can see that it's just a randomly selected summer day. And you see how the clouds develop over Switzerland. You see how the little cloud system and thunderstorms are initiated along the Alps. If you look a little bit more to the north, that you can see that the bigger system is developing and that clouds are clustering together. And of course, from the left, we have the input from the model that is coming from the global one. So I've said weather forecasts are used for a wide range of applications. And one that is particularly important for MeteoSwiss is, of course, that we are concerned about the safety of the Swiss population and about the safety of infrastructure. And living here in the Ticino, I don't have to repeat that we had a really tragic event in the MeteoSwiss. There's another one just a month later in the Matcha. We had huge damages in the Berner Oberland. So I think it was a season that really showed that the power that sits in these weather systems is enormous, and that the damage that you can generate with this weather system is enormous. Like in the MeteoSwiss, we had 8 fatalities. And this is the area where MeteoSwiss is investing a lot. We want to have the capability to really provide accurate and fast warnings so that people can save and that we can also prepare as it just is today. And I guess you have read that in the newspaper, what people now do in Austria, in the eastern part of Europe. So this is all based on weather forecast. And weather forecasts, by the way, are based on HPC and in the end on Alps for Switzerland. And that's what makes me very proud, but that makes also Alps a very useful tool for our society. So I just show you now MeteoSwiss. This was this area here, and that was the moment, and you show the precipitation, just an instantaneous snapshot of the precipitation forecast. So the image that I'm going to show you is the one that our forecasters look at daily. So they are not as nice as the animation you just seen before. But that is the product that our forecasts explore and decide, and based on that, they do the advice to the cantonal organizations, to the police, but also release the warnings, etc. And we just passed over with this extreme system. So you see that these thunderstorms, which had led to this tragic event, has a lot of fine-scale structure. It's not just a big blob of precipitation. It's a small system, well organized along lines. And all these features we need to simulate correctly. And now, the point is, if we want to know whether this one is going to change in the future, and there is a lot of indication that this system in intensity and frequency will increase in the future, we need to be able to simulate this small-scale structure in order to explore whether climate change will have an impact and how it will change the precipitation system. And for that, we are in a community that is both very well organized globally, and I guess you all know the IPCC that is releasing reports on how we expect the climate will change in the future. But as important as the government from Switzerland, we have a process that is on the bottom line that produces climate change scenarios for Switzerland. So we take this global information and downscale and explore it over Switzerland, and we do that in very close collaboration with the ETH Zurich, and of course with CSCS, and of course with Alps, because we need to have this higher resolution in the Alpine region. And by the way, just a little note, next year, 25, the new version of the Swiss climate scenario will come out. So in order to have this simulation on global and regional scale, so Thomas mentioned that, the community is trying to develop so-called 1 kilometer climate scale models. And I'm just showing you one example. And this one is an example not in the future, it's going back to 1972 to the Apollo 17, and where the famous blue marble picture is coming from. And what you see, or what you've seen before, is that the simulation with the ICAN model is very, very similar to the photo that the people from the Apollo mission have done. So that is one thing that is, in the moment, we are able to generate such high-resolution global model simulation. Of course, we are able because we have the HPC behind. And the second thing is we are in the process to validate whether they are correct or not. But the third thing is we are also able to run the model backwards, as here in 72. We take all the data available from satellite, from observation, ship observation, balloon sounding, etc., recalculate your numerical model, and generate by this a huge data set of the past climate. And that's exactly the base for all the AI model that you hear today from weather and climate prediction. So it's this data set that is sitting in Bologna, where CSCS has this link established, and it is this data set which is somehow, if you like, the fuel from the AI modeling, which is currently very much developing very fast. So, and that brings me to this slide here. So it's clear, AI is a revolution for weather and climate. Weather and climate is very well organized in data. We have with this reanalysis data set a unique source of data which has been used by all big tech companies as well. So most models that you hear today from are based on the SMWF reanalysis learning. And CSCS and the Alps has a fantastic link to this data set. And the Alps has the power to do like a foundation model. So what should I say to the end? I think it's all about collaboration. I mean, given that we have Alps, and given that we have SMWF and your connection to Europe, but it's about collaboration. And I'm very much convinced, or I know that we have built up in the last 10 years, 20 years, an excellent collaboration in Switzerland. It's one that for MeteoSwiss is very important, is this ETH, CSCS, Center for Climate System Modeling exclaim connection that is very well established in the weather scene. Then, but just as important is, of course, the connection to the Europe, to ESMWF, EUMETSAT, to our partners in the COSMO Consortium. And then, of course, the new initiative, the Swiss AI initiative, will bring us the chance to bring this knowledge together. And Switzerland is a small place. So if we work together, so we have a unique opportunity, in my opinion, and I'm very much convinced. And so I say thank you to everybody here. Thank you also to the politics. I mean, I think it's money that really flows out to the society, to the economy, and it gives a very nice image of Switzerland in the international scene. That's all. Thank you very much.